Are you struggling with emissions piling up in your Flux.interval? It can be really frustrating when your functions take longer than expected, right? Well, you're in the right place. Today, we're going to tackle how to slow down emissions from Flux.interval effectively. I totally get it. You want your function to run at a steady pace without queuing up emissions, especially when the processing time varies. You're not alone in this. Many developers face similar challenges when working with reactive programming. Here's the specific question we're addressing today. One user asked, "How can I slow down emissions from Flux.interval?" They provided a code example where the spin function sometimes takes longer than the interval, leading to unwanted queuing. Sound familiar? Let's dive into this together. So what's happening here? When you use Flux.interval, it emits items at a fixed rate. If your processing takes longer than that rate, emissions can pile up, causing a backlog. This is a common issue in reactive programming, but there are ways to handle it. And stick around. I have a great solution for you at the end that will help you manage your emissions effectively. To prevent emissions from queuing up in the Flux.interval, the user can implement a delay mechanism. This will ensure that the spin function is executed no earlier than 2 seconds after the previous invocation. The user can achieve this by using the delay method in the Flux pipeline. This method will introduce a pause before the next emission occurs. Next, the user should modify the spin function to return a mono that completes after the specified duration. This will help in managing the timing of emissions effectively. Finally, the user should ensure that the Flux.interval is subscribed to the modified spin function. This will ensure that the emissions respect the timing constraints. Fun fact: did you know that reactive programming can help you manage asynchronous data streams more efficiently? It's like having a personal assistant for your data. Now, let's look at the answers provided by other users. One alternative approach to slowing down emissions from Flux.interval is to use the delay elements method. This allows you to introduce a delay between emitted events. For more precise control, you can utilize the delay until method, which lets you specify a condition for delaying emissions. That's all on that answer. Let's take a look at another one. An alternative approach suggested by a user involves explicitly managing the subscription to control emissions. They recommend using a subscriber that requests the next item only after completing a long-running task. In this method, the subscriber requests one item at a time. After executing a potentially long operation, it requests the next item, preventing any backlog of emissions. Here's the pro tip I promised. Always monitor the execution time of your functions and adjust your intervals accordingly. This simple habit can save you from a lot of headaches down the line. And there you have it. You now have the tools to manage emissions from Flux.interval effectively. Remember, controlling your emissions is key to smooth reactive programming. If you found this helpful, hit that subscribe button for more tips and don't miss our next video.